Alright, welcome back everybody, and today we're going to be talking about power. And you guys should know that power in terms of physics is the amount of work you can do divided by the amount of time. So the more work you can do in a less amount of time, the more power you can produce. So let's look at this example. An electric motor lifts an elevator 9 meters in 15 seconds by exerting upward force of 12,000 newtons. What power does the motor produce? So I'm going to roughly kind of draw this. So we have this motor here. Not the best drawing. The motor here. It's wrapped around. Let's say it's pulling up this elevator, right? So it's pulling up this elevator. As it's pulling it up, it's lifting it up with a force of 12,000 newtons. And it's lifting it up 9 meters. 9 meters in 15 seconds. Okay? So that's what we got here. So let's try to figure this out. First, let's just figure out what the work is. Work is equal to the force, which is 12,000, times the displacement, which is 9, times cosine of theta. And in this case, the force and displacement are in the same direction, so cosine is going to be equal to 0. So we can now say that the work is equal to 12,000 times 9, which gives us 12,000 times 9. 108,000 joules. So that's how much, 108,000 joules. That's how much work this motor did onto this elevator. And now we know work is equal to power divided by time. So we can do 108,000 joules divided by 15 seconds. Divided by 15 seconds, and we get 7,200 watts. Okay. If we wanted to convert this into horsepower, we're going to divide by 746, and we get 9.65 horsepower. Okay. But you're usually going to see it in watts. All right, let's move on. To pass a slow-moving truck, you need your 1,300 kilogram car. So this is the 1,300 kilogram car to accelerate from 13.4 meters per second to 17.9 meters per second in 3 seconds. What is the power required to pass? Okay, a little bit difficult maybe to see at first, but we should know that power is equal to work divided by time. And we should also know total work is equal to change in kinetic energy over time. So let's see if we can figure this out. This is going to be equal to 1/2 mass, 1,300, V final, which is 17.9 squared, minus 1/2 times 1,300, V initial, which is 13.4 squared, all divided by the time of 3 seconds. So let's put that all into my calculator. 17.9 squared times 1,300 times 0.5 minus 13.4 squared, 1,300, 0.5 divided by 3. And then what we get around 30,517.5 watts. Okay. So just remember, you're going to see some things like this. Just remember all the ways we can find work. There are many ways. All right, let's look at this. It takes a force of 1,280 newtons to keep a 1,500 kilogram car moving with a constant speed up a slope of 5 degrees. Okay, let's just write some things. This is 5 degrees. This is 1280 newtons. Oh man, I'm mixing up my words a lot today. 1280 newtons to keep moving constant speed. If the engine delivers 37,300 watts, what is the speed of the car? Okay, so this one is going to be a little bit tricky. Maybe take some time to think about it. We should know again, power is equal to work divided by time. Let's kind of write this out a little more. Is equal to force times displacement times cosine theta divided by time. One thing we don't have to worry about is the force and the displacement are going the same direction, so this just turns to 1. But another thing we can figure out is force. We also know that displacement over time is equal to velocity. So we have another formula here. We have power is equal to force times velocity. And we can only do that when we have a constant speed, okay? So when we don't have a change in speed, we can use this formula to figure out, in this case, what the power, not what the power is, what the velocity is. So let's figure that out. Power is equal to 37,300. Force is equal to 1280 times the velocity. And velocity is equal to 37,300 divided by 1280, 29.14 meters per second. Okay. All right, last one here. A man lifts a 10-kilogram box 3 meters above his head with 150 newtons of force. How much power does he produce? Okay, so let's see. Force of gravity, force applied. Force applied is 150 newtons. Force of gravity is 100 newtons. So let's see. Work done by the force applied. Force applied is 150. Displacement is 3. And it's going in the same direction, so it's going to be cosine of 0. So this gives me the work applied 150 times 3, which is going to be 450 joules. Now I know that power is equal to work divided by time. However, we don't know what this time is right now. So we have to first figure out what that time is. So let's see. We know he's going to lift with an initial velocity of 0. We know that he's going to move it up in the y direction 3 meters, but we need one more piece of information before we can find time. So we need to find acceleration. So I'm going to find the acceleration doing the sum of all force in the y equals mass times acceleration in the y. So force applied, 150, minus force of gravity, 100, is equal to the mass of this, 10 times acceleration. And then we can do, this is going to be 50 divided by 10, so 5 meters per second squared. So now we know acceleration 5 meters per second squared. And let's see if we can try to find this time. We're going to do displacement in the y equals v initial t plus 1/2 at squared. So this is going to be 3 is equal to 0 plus 1/2 5 t squared. Let's do some algebra. 3 times 2 divided by 5 square root. We get t is equal to 1.1 seconds. So now we can plug this all in. Work is 450, time is 1.1, and we get 450 divided by 1.1, and we get 409 watts. Okay. All right, guys. Thanks for watching. And next time we're going to be learning about work non-conserved, combining what we learned with energy with work. All right. See you next time.